Good day. In today, we will look at the maximum height. How do we derive the equation for the maximum height? But before we go ahead to derive the equation for the maximum height, we will first define what we mean by the maximum height. Don't forget, this is still under projectile. The maximum height under this topic is the highest vertical distance attained as measured from the horizontal projection plane. Go to this drawing of mine. The maximum height is represented with this capital H, which is the highest vertical distance attained as measured from the horizontal projection plane. The horizontal projection plane is this line. This line is the horizontal projection plane. Okay, good. To find H, we use one of our equations of motion that we already know, which is v squared is equals to u squared plus 2as. V squared is equals to u squared plus 2as. But don't forget, we have said that for a projectile, when the projectile is moving upward, we should use a is equals to minus g. And we have said that instead of s, we should use small letter h. Don't forget, in the equations, in the video where we differentiated between writing the equations for an object moving on the ground in a straight line, an object thrown vertically upwards, and an object thrown at an angle to the horizontal, which is of course a projectile. We wrote the equation for a straight line motion for an object moving on the ground. We wrote the equation for an object that is thrown vertically upwards. We also wrote the equation for an object thrown at an angle to the horizontal, which is of course a projectile. Alright, so using that for a projectile, that gives us this equation, which is what v squared is equals to u squared minus 2gh. Recall, the vertical component of velocity of projectile is, yes, this velocity, because it's thrown at an angle, at an acute angle to the horizontal, it will have effect along the vertical, and it will also have effect along the horizontal. Okay, look at my cursor. It will have an effect along the horizontal. It will also have an effect along the horizontal, and it also have effect along the vertical. All right, so what is the component of this u? The initial velocity of the object along the horizontal, that would be u cos theta. Along the horizontal, it will be u cos theta, and along the vertical, it will be u sin theta. The effect along the vertical will be u sin theta. Okay, so that is why here we wrote that v subscript v, which that is the vertical component of the velocity, will be u sin theta. And if we now put this u sin theta into the equation above, we will have v squared is equals to u sin theta square minus 2gh. Okay, good. Now, why did we use u sin theta, which is the vertical component? Don't forget, we are interested in getting the vertical height. Okay, we are interested in getting the maximum height attained by the object. Okay, so at the maximum height, we will make our h to be the capital H, and our v will make it to be 0. Don't forget, when the object moves this way, okay, following the parabolic path, by the time it gets to the maximum height, the only reason why it stops going up and starts coming down is because the velocity here has reached 0. don't forget, when it's coming from here, it has been thrown with a particular velocity u, which is the initial velocity. So that velocity keeps decreasing as it's going up until it gets to the maximum height, where the velocity now becomes 0, and then it starts to come down. Okay, as it's coming down, the velocity begins to increase from 0 to the maximum just before the object drops to the ground. Okay, so velocity is 0 at the highest point. Hence, we can write that 0 is equals to u square sine theta minus 2g capital H. Okay, so if we make capital H the subject of formula, that is, we bring 2gh to the other side, so that will be 2gh is equals to u square sine theta. Then we divide both sides by 2g. That will give us h is equals to capital H is equals to u square sine square theta, all divided by 2g. All right, so this is an equation or a derivation that we can always use whenever we want to calculate the maximum height reached. Good. Then we go to the range R, represented with capital letter R. So by the range, this is where we want to calculate. This is where we want to calculate by the range. But before we do that, before we derive the equation for range, we'll first define what range is. Range is defined as the horizontal distance from the point of projection to the point where the projectile hits the projection plane again. That is, the horizontal distance from the point of projection to the point where the projectile hits the plane again. Okay, so horizontal distance from the point of projection, this is the point of projection where the object is thrown at an angle to the horizontal, to where the projectile hits the projection plane again. This is where the projectile hits the projection plane again. Don't forget, this is the projection plane. Okay, so the distance between here and here is our range. Okay, now the time taken to travel this horizontal distance, let's make it capital letter T, okay, which is the time of flight. That is the time taken to go from the point of projection to the point where the projectile hits the projection plane again. Okay, and that is v vertical is equals to u cos theta. So in this case, we are going to be using the horizontal component of the velocity. We're going to be using the horizontal component of the velocity. Sorry, this is VH, that is horizontal velocity. Okay, because we are interested in calculating horizontal distance, which is the range. Okay, so which is the horizontal component of the velocity? All right, we can then write that our range, don't forget, is distance. Distance is equals to velocity times time. Okay, distance is equals to velocity times time. So for our distance, which is our range, r is equals to velocity, which is u cos theta, then times the time, the total time it took to go from the point of projection to the point where the object hits the projection plane again. All right, so r is equals to u cos theta times 2u sine theta, all divided by g. I hope you remember where we got this from. We have derived an equation before now in terms of our time of flight, capital T. Okay, so if we make if we multiply here, we will have 2u square sine theta cos theta all over g. 2u square sine theta cos theta all over g. Okay, and from trigonometry, 2 sine theta cos theta is equals to 2 theta. Okay, so that is obtained from our trigonometry. Okay, so in terms of I can just rearrange this equation and write that r is equals to u square. I'm left with 2 sine theta cos theta, and that from trig is sine 2 theta, all divided by g. So our r is equals to u square sine 2 theta, all divided by g. Okay, so whenever we want to calculate for our range, we will use this equation. R is equals to u square sine 2 theta, all divided by g, all divided by g. Note that the range is maximum when 2 theta of the above equation is maximum, and this will only occur when theta is equals to 45 degree. Okay, so if I put theta to be 45 degree in this equation, that will give me 2 times 45, which is 90. Okay, and sine 90 is 1. Okay, so at that point I will be left with u square or divided by g. Okay, at that point, that's when I will have my maximum range. Okay, that's when I will have my maximum range. So if the projectile is projected at an angle 45 degree to the horizontal, that is when I will have the maximum range. Thank you for your listening attention. Hope to see you in the next class. Bye.